Okay,
Oh, the census.
Oh.
the math professor is on the air once more.
Yay. Oh. Yeah, that one. That one. Ooh, their hand sanitizer.
Strong.
Yes.
Oh my gosh.
Bringing back awful flashbacks. They're like, woo, that's strong.
Oh dear. What did you do? Just kidding.
I gave them to my sister. Here, look, I got this for free. She says, Elsa, give it to me.
There's always somebody that'll take the free stuff.
Yes.
Freeze.
My sister's like that. She's weirdo. Like anything that's on sale or reduced sale or free, she's always grabbing, even if we don't need it.
Never know, right?
I get mad at her. Stop doing that.
Second, we're talking about the second wave.
Yeah.
So I'm buying toilet paper as you go.
When they say the second wave, are they referring to the,
Second wave is when how many more millions of people or thousands of people?
So I wonder if I wonder if they can get reinfected again.
Yeah, remember there was one case already? One person it came back to him, but his symptoms are different. It's not the same.
Worse?
Yeah, yeah.
That's what I'm scared of.
Like, oh my God.
It just about killed me the first time. It's crazy.
what, how many times have you had this? 500, 1,000?
Yeah, it feels like it.
Yeah, there's already one case.
I read about that somewhere, yeah.
Yeah. It's like, oh, Lord, just shut the world. Are we gonna go back to lockdown again this weekend?
He,
Oh, no!
he said, we're gonna have lockdown until they come up with a vaccine. I
Does he
said,
realize that it took 30 years to develop a vaccine for polio?
he's probably not aware of that, sir. I was like, really? We're gonna be locked down
Back
this
to
year,
50.
next year?
Is it back to 57 hour or?
Just
32?
32.
That's good.
All right, let's start talking about class stuff then. So only if you can figure out how to manage the project for vaccine will we talk about that. All right, I posted this on Moodle for you. Have any of you looked at it?
No.
No.
Hell of a job. Okay, I should have put BUS-352 / there. All right. All right, project. For the project, students must find a project desirable for the Navajo Nation that would be completed in a multi-year period. Okay, so don't give me that week-long project that you've been thinking about. Any project presently planned or not planned that would benefit the Navajo Nation may be used that would have a duration of over a year. Students may, if they so desire, work in groups of 2, but in so doing, they must understand that the rigor of their project and the results must reflect that extra effort. Now, I've actually only had 2 students work together to produce one project, and they did a hell of a job. 2 of our outstanding students that graduated, I guess, within the last few years. I can't remember exactly the time frame. Analysis. Students must use appropriate methods to create a work breakdown structure for the project and a schedule with network node analysis that accounts for the possibility of finishing early, finishing late, early or late start for each individual module of the schedule. You're probably saying, what the hell is he on about network node analysis? We haven't actually come to that part, right? So right now, what you would be doing, assuming that you're not going to work on your project the night before you have to present, is to start with the work breakdown structure, right? Since that is the part where we've kind of been through. The following elements must be included: risk analysis, risk mitigation and contingency plans for risk elements, projected budget with total cost, possible governmental or bureaucratic delays, work breakdown structure, network node and critical path analysis, obtaining right-of-ways if necessary, not all projects would require that, resources needed, and other elements or tools that a student might think would be necessary for the project. Presentation. Students must present a complete overview of the project to the class using PowerPoint or other visual aids as appropriate. All required elements from the analysis section must be included. Project presentations will be scheduled for November 3rd and 5th. Okay, and usually how I do that is I do a random draw to see who gets to go first and who gets to go second and so on. Each presentation should be 20 minutes for an individual student project or at least 35 minutes for two students working together. Actually, the one time we had two students working together, they ended up sucking up most of the class time. They were so excited about their project. Students,
Can I ask what their project was on?
I was afraid you were gonna ask that. It was building some kind of facility for the Navajo Nation. I don't remember exactly what at this time. But they had gone into it very thoroughly. I mean, they had how much money it would cost to get the design, how much money it would cost to buy the piece of land they had in mind. I mean, they had everything laid out to it fairly well. Students will submit a 5-page report exclusive of title page and references. So that's 5 pages of actual writing. You can do it, don't worry about it. On the project, going through all elements of analysis, scheduling, risk, and other considerations necessary for the project. If 2 students are working together, the report size required is increased to 10 pages. Grading. Presentation and reports will be graded at 50 points each, with project management standards, clarity of thought, neatness, and professional look all being considered. Student input will be part of the grade for the presentation. In other words, your peers will get to score you as well as me. Minimum elements for the project. complete explanation of what the project is and why it's necessary, budget with total cost, work breakdown structure and network node analysis, schedule, risk chart rating risks, methods of mitigation, and contingency planning.
Easy, Miss Cheryl. If you can do business plan, this is someone.
That's what I was just
Exactly. Thank you for that, sister.
Amen.
All right, we're gonna have our little revival here. Okay, look, if you do this at the same time as we're going through these various elements, should be a lot easier, right? But I've had students come up to me at the end of the semester, I don't remember how to do network node analysis. Well, I mean, we don't spend that much time on it, but still. So, look, there are plenty of projects that would be of value to the Navajo Nation, right? I had one student did a project on creating a series of gyms across the Navajo Nation so people would have a place to go and work out and stay in better shape. I've had projects on old folks' homes for the Navajo Nation, for veterans' homes for the Navajo Nation, how to promote small small garden and farm irrigation.
Oh, wow.
I mean, you know, if you have an idea for a sheep breeding for the Navajo Nation, as long as it's of value to the Navajo Nation, and I'm usually pretty loose in what I define as of value to the Navajo Nation. It really shouldn't be hard. All of you have ideas about how the Navajo Nation could be made better. For that matter, if Rebecca had ideas about how to improve NTU over a multi-year period, that actually our first capstone class did that. They did a 10-year project plan for how to make NTU better and improve our facilities. And it was really brilliant. It was so well done. I'm gonna get choked up here thinking about it.
Oh.
So, not to mention, this is the kind of thing that if you do a really good job and you go out and you're getting a job, then they say, well, we don't know, you know, you've just been in school, you haven't really been out in the workforce. You can say, well, that's a very fair thing, but let me show you this project plan that I developed for to, you know, do whatever here on the Navajo Nation.
I'm so excited. I have so many ideas.
Good, I'm glad to hear it. All right, am I not in a meeting? All right, so, all right, let's stop that share and we'll go to another share, which is our exciting Chapter 5 PowerPoint presentation. All right, so we've been talking about estimating, and I'm going to assume I meant to start on this slide even though we've gone through it already. So we've got direct costs. Again, we can charge that to a specific work package. We've got direct project overhead costs. So that might be, we have an office or a big workroom for our project that we're using exclusively for that. And then again, there's the general and administrative overhead costs. Uh-oh, this is not good. All right, I think actually this is where we should be. Why I wrote down 22 instead of 24, I'll never know. All right, so here we have three views of how to think about the cost. One is the committed budget, which is this solid line at the top. Is it coming out? Sometimes the graphs don't come out well on the projection. All right, so the solid line represents our committed budget. Our this dashed line in the middle is the scheduled budget. And then the dotted line here at the bottom is the actual cost. Now this is really ideal that we stay below our scheduled budget and our committed cost. I have seen the scenario in the past where you get down close to the end and all of a sudden there's an orgy of spending to spend all the money before the project's over. But remember, you're going to be judged not only on how well the project goes, but how well you've managed it in terms of time and cost. So if you come in under time and under cost, that is a big plus. Now that's different if your customer has committed a certain amount of money. So for example, on one of our contracts at the Corpus Christi Army Depot, the director of our division and I, at the last minute, did spend all of the money except $4.36. Right, so it's a bit different depending on, is this the customer's money or is it the company's money? Right, if it's the company's money, you want to spend the least you can, get good results in a timely fashion. If it's the customer's money, you certainly want a timely fashion, but we may just go ahead and spend all the money and the hell with it. All right, so we've got our estimates of time and cost, but one of the parts of the process is we want to refine them. We want to make our estimates as good as we can, because if everything is based on your estimates, and you come in really, really, really far below the budget, they may not believe you the next time you present them a budget. Right? We do want to be under budget, but we want really good estimates of our costs in the first place, right? We may not get a job from a customer or from the company if we give them an estimate of time and costs that they're like, man, we can't possibly commit that. All right, so we're going to adjust the estimates, and there are some reasons we might do that. Our interaction costs may be hidden in the estimates, right? And that might mean that when we look at it carefully, we might say, you know what, this is a little high, or this is a little low. Let's kind of add a factor in there. Normal conditions might not apply, right? We make our estimates based on normal conditions applying, but damn allergy season. But normal conditions might not apply, right? This might be an emergency project, crash dive to save the company that causes our normal condition situation to be totally out of whack. Things do go wrong on projects. That's something that's just going to happen. You can't count on everything going perfectly. That goes along with that normal conditions do not apply. And the risk is going to be greater if you're fooling with technologies you don't know, we're dealing with maybe suppliers that we don't know very well. So there could be problems there. We might have changes in our project scope. That's always a big bugaboo. We have a term called scope creep, which is, you make a deal with the customer and you're going to do X, Y, Z within this project. Everybody signed off on it. A month later, the customer comes to you and says, could you do W and X, Y, Z? There can be changes in the project scope. Our plans, we may have to change. Say we're planning on using the company's R&D development building, right? They're going to give us a corner in there. And the day after we set our plan, they burned the building down by accident. They're developing a new kind of flamethrower and they forgot a safety catch. Or whatever. All of a sudden we can have a situation where resources that we were counting on, personnel that we were counting on, even money that we were counting on, time we were counting on, any of those can disappear, right? We're going to develop a new product for the company. They get wind that one of our competitors is developing something similar, all of a sudden, it's a crash emergency trying to develop this project. Well, another reason is we might have been overly optimistic. If you have one of those Pollyanna managers who always assumes we can do more in a given time than we can actually do, this is actually one of my faults as a project manager. I always think I can do more in the project than is probably prudent. And there might be a strategic misrepresentation. That might come from within our own company or from the customer, or from, for that matter, from the technologists within our own company that are telling us, oh yeah, we can do this, we can do that, we can do the other thing, right? And then when it comes time, they're like, we can't do that. All right, so we're going to be adjusting our estimates, both the time and cost estimates for each specific work package or activity, as we understand better the risks, resources, and situation particulars, right? Because that's going to become clear over time. And as the project manager, you're going to end up doing that almost until the very end of the project. Now, we may not have to do huge changes, right? But we may see some risks on the horizon, and we plan against them that end up not coming true. Or they come true, but then it turns out our contingency plan was actually not as well thought out as we thought. Too many thoughts in that sentence. So there can be reasons that we're going to have to keep adjusting our estimates. As I said, that can go pretty close down to the end of the project.
And that's allowed.
I'm sorry?
And it's allowed.
Well, it's going to be necessary. If we're going along and we're making reasonable progress, and we find out our competitors are developing the same kind of a product or service, all of a sudden we may need to look and say, you know what, that means that the risks of somebody else, we've already got in the risk matrix somebody else coming out with this product or service. Well, that's just gone from low to high, and we need to adjust our plans accordingly. So yeah, adjustments are going to have to end up being made all the way around. All right, so there are different kinds of estimating database templates. Some of them are going to be based on the hardware that we're talking about using or making, the production of the actual product, how hard it is to program, right? And a lot of these have like formulas in the background that you can use to, you know, like, it'll be kind of a math formula. It won't be that complicated usually. There won't be 97 inputs that you have to track down. Or some people will want the 97 inputs. Always an exciting time when that happens. Our information system is usually going to contain some kind of data that would be helpful to us. Okay? 5 years ago, we did a similar project. Here's the project plan, the budget, everything that went into that, right? We may be able to use that as a template and just say, all right, how much more does everything cost now than it did 5 years ago? Or ours may be kind of like that, but we're going off in another direction. We can still use some of it, but not all of it applies. What are the operation processes that go in? Our risk analysis is going to make a difference. If it's a super high risk project, we may get shut down before we even really get started. We're still in the planning phase, because the company is just like, you know what? This is kind of an uncertain time. We can't take on another high-risk project. Or it might be low risk, but they look at the cost and they say, holy crap, we don't have that kind of money. That's like Zuckerberg money. Right, and the documentation, right? So all of these would be sources that we can use for estimating time and cost. But we should always keep in mind that things may have changed. They've probably changed. And that we need to be cognizant of what is different about our project from the projects we're comparing to in the past, and make allowances for that. All right, so then we come into the mega project area. Mega projects are defined as large-scale, complex ventures that typically cost $1 billion or more, take many years to complete, and involve multiple private and public stakeholders. So, high-speed rail lines, airports, healthcare reform, don't get me started on that one. The Olympics, the development of new aircraft, all of these could be a mega project, right? Other mega projects might be huge dams, a new highway system that cuts through where there's really no highways now. Nuclear power plants. The Dallas Cowboys Stadium cost over $1 billion. I shouldn't have brought that up. I'm mad at the NFL.
Why?
The whole caving to BLM and kneeling it's all pissing me off.
And then what do they do now? They even change the Washington Redskins name to, isn't it?
To what?
Something national, something,
Yeah, they're calling it like Washington football team or
something.
national something. I don't know. It doesn't matter. I mean, the only sports that I really were watching were Dallas Cowboys games when I could get them. and that was rare enough. I would much rather play sports than watch.
And then they're talking about the Chiefs too, right? Yeah.
Oh, yeah.
Yeah, they're.
Well, they'll get to the Cleveland Indians and the Chicago Blackhawks and everybody else before too long. All right, so when we have a mega project, we often have the problem that you have cost overruns and it doesn't give you all the benefits that you were expecting. Sometimes they turn into white elephants. Because they're over budget, they're undervalued, they have a high maintenance cost. You know, it's kind of like, why did we do this? Las Vegas is kind of experiencing this right now. They've built a football stadium so the Oakland Raiders could move to Las Vegas. But they didn't really think about, I mean, the Raiders essentially own all the time of the stadium, and they won't let the local college teams play there. They don't have any concerts or other things lined up. So they've got this huge, expensive thing, and now the Raiders are kind of like, well, we don't know if we're going to move there or not.
Oh.
All right. So when we talk about reference class forecasting, which is kind of what we're talking about when we say you look at the production processes of our new product from the view of the production processes that we had before. So we do want a reference class similar to the potential project, right? If we're doing a marketing project, we don't go down to the production floor and talk to the production manager because that's irrelevant to marketing. We need to be in there talking to the marketing guys. We want to look at the outcome data as a statistical distribution. And look at the cost overruns as a percentage of the original project estimates. Okay, I don't know how familiar you guys are with statistics. Christine actually asked me to look over the business statistics book that they're going to use in their class. And it's all pretty straightforward. There's no reason that y'all couldn't take our statistics that we teach in industrial engineering and run with that. I mean,
what is it called, industrial statistics?
No, it's just statistics.
Oh,
I mean, when you slap a label on there like business statistics, it doesn't change the fact that it's statistics.
that's what I think is very strange and kind of, like, we have to take Math 213, that's regular statistics, and then it's in our graduation list to take. So we actually have to take statistics, and then we have to take business statistics.
For the elementary statistics, then business, right?
Yeah.
Yeah,
And they're both the same thing,
exactly.
same thing.
Well, see, y'all might benefit from taking it in the IE courses because we split the statistics class in half so that, like, I teach the basic probability and statistics, which is half of the course, and then Dr. Ramoni teaches the inferential statistics part. Because part of the problem is, when you took elementary statistics, how far did you get? Did you do hypothesis testing or fitting lines to data?
No.
No.
Just as I suspected.
So it was bad then?
No?
Not necessarily, because like when I teach basic probability and statistics, I only teach up through confidence intervals, tolerance intervals, and prediction intervals, so that we can spend more time on the subjects and make sure that the students are understanding what's going on. Because a lot of times statistics courses, they're rushing through there so fast, the students just fall into a confused slumber. Apparently Judith has had that experience.
Oh, I've had that experience as well.
We all did. But we managed to get through it.
Well, that's actually something a friend of mine told me once when I was going to school. He said, it doesn't have to be good, it just has to be over.
Yeah.
All right, and then we use that distribution data to look at a realistic forecast. We're going to look at the original cost estimate for our project and look at the reference class projects, right? And we can break that down to the individual sections of our project, like the documentation, like the production process, like the engineering process, like, you know, like all the parts of the different projects. All right, and here we have our key terms. One thing I can promise you, I'm not going to ask about white elephants on any quizzes or tests. Do you all know the story behind white elephants?
No.
Well, I can't fill up the next 35 minutes with it, but in India, it was considered to be a great honor to be given a white elephant. You know, elephants are ordinarily gray, but occasionally you get one that's born an albino.
Albino?
Albino. But the problem is, if they gave you a white elephant, you were expected to do all this other stuff. You know, you had to have people wash it every day, and they had to feed it a special, more nutritious brand of hay, and all this other stuff. So actually, being given a white elephant was a way of giving the middle finger to somebody.
Oh gosh. So thank you for not giving us white elephants.
Oh, gee.
Whatever I can do, of course. All right, so are there any questions on chapter 5?
No.
Then let us plunge boldly into chapter number 6. Maybe I should mention on your project, if at any time you feel confused about that, feel free to email me or come by and talk to me about it. It's not a problem. I know some professors, you show up and they're like, what do you want? Oh, sorry. No, I'm kidding. Usually my experience is that
You know
professors
what?
are very helpful. I did have a professor greet me that way once, but that was actually here, and he wasn't my teacher. I had just shown up to see if he wanted to have coffee.
Oh.
Well, when I was greeted that way, I was kind of like, nothing, have fun, everything's okay. All hands, man your non-panicking stations. I don't know if y'all noticed, but we switched over to the 7th edition slideshows.
Oh, when did that happen?
That happened very recently. I finally got a chance to call McGraw-Hill, say, what the hell is going on here? How come I can't download it? And the lady was very nice. She said, you dumb bald guy, it's right up there in the corner. Push that button. Okay, I think we've all learned a valuable lesson from that. All right, so we're going to talk about project networks. So we want to know what is the linkage between our work breakdown structure and our project network. We want to diagram a project network using arrow on node methods. This is the network node stuff that I was talking to you about before. We want to be able to calculate our early, late, and slack activities times. Of course, they tell you all this before you even know how to do early, slack, and late times. Identify and understand the importance of managing the critical path. Distinguish the free slack from the total slack. And demonstrate an understanding and application of the lags in compressing projects or constraining start or finish of an activity. Okay, so inevitably, when we do a project, we're going to have parts of the project. We're going to have parts where we say, you know what, we need 60 days to do this part, right? But we're going to have other parts where we say, 5 days, 10 days, 1 day. So, because they're not all going to match up, that means that at times we're going to have slack where we can say, you know what, that 10-day project doesn't really have to be started right this minute because the activity that starts after it has to wait on this other part of the project as well. All right, so developing our project network from work package to network, constructing a project network, activity on node fundamentals, network computation process, using the forward and backward pass, or lateral occasionally. No, I'm lying, there's no lateral. And information. I don't know if that just was waiting to start or what. The level of detail for our activities and practical considerations. Boy, That is a lot to cram into 42 slides. Two of which have already gone by. Oh, even more, extended network techniques to come,
Long chapter.
closer to reality. Okay, I can see that I should work on the animation on that slide. All right, so what is our project network? It's a flow chart that graphically depicts the logical sequences, interdependencies, and start and finish times of the project activities, along with the longest paths through the network, the critical path. So it gives us a better basis for scheduling our labor and equipment and other resources. It enhances our communication among our project participants, right? We can have that big project network diagram on the wall so everyone can see where we are. It gives us an estimate of the project's duration. It gives us a basis for budgeting our cash flow, helps identify activities that are critical, highlights the activities that are critical and shouldn't be delayed, and it helps us to build and to stay on a plan. All right, so here we have a very simple project that we're making a circuit board. We don't know what this circuit board does. We assume something important and exciting. And so we have certain work packages that are going to go into that, right? So we have the design, right? That ends up being two different work packages, the specifications and the documentation. The production, where we make a prototype and we test that, and then we make the final prototype, which will be very much like the actual circuit that will be produced. We have a testing work package. We have two work packages for software, the preliminary software and then the final version of the software. All right, so in our network, design has to come first. But producing the first prototype and producing the preliminary software can go at the same time, right? So that's why from A, it splits into those two. Both of those have to be done to begin building the final prototype, which is needed to do the final software, and then we test. Right, so all of these are given an amount of time that is going to be needed for them, right? So unless this is like a super simple circuit board, I'm imagining that these times are in weeks or months. Right, so 2 weeks for specifications and documentation. 5 weeks for the first prototype, but only 3 weeks for the preliminary software. 4 weeks for the final prototype, 2 weeks for the final software, and 3 weeks to test. All right. So, when we're constructing the network nodes, we have terminology. We always have terminology. We call it jargon, right? So business has its own jargon. Engineering has its own jargon. And mostly those are ways of making people feel like outsiders. All right, so first of all, an activity. Requires time, right? So if there's an activity that doesn't require time, well, that's impossible by the laws of physics to begin with. If it's an activity, it has to have time. But it may not require resources, right? It may only take a guy scribbling at his desk for that activity to be completed, like a design. We have merge activities, and D here is a merge activity because 2 or more preceding activities it depends on, right? So both A and B have to be completed before we can start on D. A parallel activity is an activity that can happen independently, but not necessarily at the same time, right? So D and C both are parallel activities to each other. D relies on both A and B being done before it can start, but C only requires B to be done. We could also say A and B are parallel activities. All right. So, a path means that we have a sequence of connected dependent activities. So, A to B to D is a path. The critical path is the longest path through the activity network that allows completion for all project-related activities. Okay, so that's kind of important. The idea of critical path analysis was actually developed by NASA because they realized They had a whole bunch of things going on for building spacecraft or planning missions, so on. And they said, all of these things have to be done in an order. Some can be done at the same time, but we have to know what is the critical path where this has to be done and this has to start exactly after that is done. And when that activity is finished, another has to start exactly after that is done, if we're going to stay on schedule. All right, we also have burst activities. So that is an activity that has more than one activity immediately following it. Right? So A here is a burst activity. Right? Because B, C, and D, none of them can start until A is done. All right. These guys say there are two approaches. Nah, actually, there's more than two approaches. But we're going to use activity on node and not worry about activity on arrow. All right, so what rules do we follow when we're developing our project networks? I'm a little worried I may have to go get my book and which would involve putting my mask on and leaving for a moment.
From networks typically flow from left to right.
Right, look, when you do a flow chart for computers, it goes from top to bottom. Right? And a lot of times when we make flow charts for other things, like a business process, we would do the same. For network node analysis, we do a left to right convention. Or, I should have done it from y'all's point of view, a left to right convention. So we can't start any activities until everything that is connected to it is completed. Our arrows give us precedence and flow, and they can cross over each other. Right? It's not that if they bump together, we have some kind of lightning happen or anything like that. Every activity has to have a unique identity. You'll notice they say identify number. Oh, that's terrible English. Has to have a unique identity. I can't live with that. All right, it's got to have a unique identifier. Very often we use A, B, C, the letters of the alphabet, because we're going to also put a bunch of numbers up there, and if we use activity numbers, that can get confusing. An activity identifier has to be greater than its predecessor activities. Okay, so you can't have E happening after F, right? It has to be so that it's flowing in a logical order, right? And when we look at our work breakdown structure, we say things like, all right, what is the order this has to go in, right? We have to have the foundation before we can start building the walls. We have to have the walls before we can start building the roof, and so on. You're not allowed to loop.
No looping allowed.
That's right. If you're loopy, then you're right out. Come to think of it, I live on Sean Dean Loop. I wonder if that counts. We don't allow conditional statements, right? Looping and conditional statements would be allowed in a software flowchart or a business process flowchart, but they're not allowed in network node analysis. And we want to use common start and stop nodes. We don't want to get to the end of the project and there's like 12 nodes out here, and when they're all finished, the project's done. No, it's got to all go to one stop node. All right, so in our fundamental view on this, A is not preceded by anything, right? That is the starting activity. Whether that starting activity is the first meeting of our project team or the design specifications, whatever it is the first thing. B, though, is preceded by A, and C is preceded by B. X is a burst activity, and Y and Z are both preceded by X. They can also both start at the same time. As soon as X is done, Bob's your uncle. These guys can both start. All right. So J, K, and L are merge activity. Well, M is the merge activity, actually. All of these guys can begin at the same time, the way they have it drawn here. But all of them have to be done before we can start M. Right? So they might be different lengths of time. Right? J might be 5, K might be 10, L might be 2. Well, M can't start until the longest activity is done. And whenever we can, of course, we try and get them so that they all finish at about the same time. All right, so here, Z is preceded by both X and Y, and AA is also preceded by both X and Y. But Z and AA don't relate to each other.
Mr. White,
Yes?
do you have a screen on, or it's not showing the screen? Or are you just talking?
Well, it should be showing you the screen.
Yeah, I don't see the screen. It's just doing audio share screen like others.
Okay, well, need to speak up a little sooner next time. I'm 12 slides in, and you're only now saying you don't see the screen. All right, on to the next sensation. Our network information here we have, this would be 8 activities. We have a description of what each one is. And we have a preceding activity for each one, right? Well, except for A. A has no preceding activity. But then B and C can't start until A is done. D can't start until B is done. E can't start until C is done. F can't start until C is done. G can't start till D is done. And H can't start till E, F, and G are all done. Oh, pardon me. All right, so we're going to look at this and we're going to start putting together our network node diagram. All right, so we want to define the requirements. Well, kind of a smart thing to do in any project. And once we have done that, we can assign teams and we can design the hardware. Now they're saying this project is an automated warehouse order picking system. Okay, so this is a process that is very well known. I mean, that we're not breaking any new ground on this project. You can go on YouTube and pull up videos of Amazon fulfillment centers and start seeing how complicated that can get. All right, here's where they put everything together as a network node diagram. Well, at least the beginnings, because we're missing some of the information that we're going to use down the line. All right, so automated warehouse order picking. It may astonish you to find out that I've had an entire course on how to do warehouses, and part of that, of course, was the order picking system.
A whole class on how to do warehouse design?
Well, not just the order picking, that was only part of it. But yeah, what is the equipment you can use in warehouses? How do you decide how big a warehouse you have to have? How do you decide what goes near the front? What do you hide in the back? Look, there's no subject that you can't make it complicated enough that a graduate class cannot be taught about it.
That sounds like so much fun.
Well, you gotta have the right kind of mind to really enjoy that kind of a class.
I can imagine.
And engineers tend to be very detail-oriented, very interested in how technology goes together. So for me, that was an interesting class. I think some of my classmates were not enjoying the class as much as I was. But that's the nature of classes anyway. young Judith is just wishing that this class was over. And luckily, we're getting very close.
Hang in there, Judith. 5 more minutes.
Now, I'm just picking on Judith. She may be enjoying this class more than anyone. But, all right, so we have the basic outline here of what our network nodes are going to be for an automated warehouse order picking system. All right, so hang on, let me stop sharing for a moment. Okay, why are you fighting me on this? All right, let's go here. Amazon warehouse. Oh, okay. Let's say video. Ah, there you go. All right. We don't have any sound.
Well, we can probably look at it ourselves, right?
Yeah, I mean, there are literally hundreds. Take back the Senate. I don't care about that. All right, see, but they're trying to show you super fast what is the process to get fulfillment, right? So you have people going online. They've got this big fulfillment center.
I would be interested to work in one of those centers.
Right?
Yes.
Yes.
But look how many of these things are automated. Things are, that's the size of it, 59 football fields.
Oh my God.
There are little robots running around. There are automatic conveyors. There are robots that are moving pallets, right? See those little robots there?
Mm.
Right? A lot of things are operating on barcodes that the robot is reading as it's driving over them.
Here's your orders.
Right? Well, you have human workers that do certain parts of the task. But don't worry, Jeff Bezos will get rid of them as soon as possible.
I can't believe Jeff Bezos is from Albuquerque.
Okay, why not?
It's amazing. Well, I can't believe it, but it's amazing that someone so close not to where we're at had a brilliant enough mind to think of all that.
Well, remember, Bill Gates is from Albuquerque.
Him too.
You know, being smart is not confined to the two coasts, east and west. Yet, I am sure that there are people, maybe even people in this room, that have $1 million ideas that could start on the path.
Yeah.
Okay, Rebecca was looking at me like, yeah, I'm the one.
You can even buy a toilet bowl on Amazon.
All kinds of stuff.
Well, I mean, you can pretty much buy anything on Amazon. Now, my problem is, I don't want Jeff Bezos to have any more money.
You know
So I don't shop at Amazon.
what?
If I go online and it says something's part of Amazon, I won't buy it.
Walmart is actually launching their Walmart Plus that is going to be like just like Amazon Prime, and it's going to be free shipping, and
See?
it's going to be discounted. You can even get like a discount card for your gas.
Like Sam's Club.
Yeah.
Woohoo!
Well, Walmart's another crony capitalist.
Yeah.
Don't get me started about Walmart.
Well, it was-
I'm also boycotting them.
Oh yeah.
I just hope I don't have to start boycotting the cafeteria, because,
Oh, yeah.
Long time ago.
okay, well, class essentially is already over. Thank you so much. We will meet again on Tuesday. Please have a safe weekend. I can't afford to lose any students.
Okay. Will do.
All right, have fun, Lyndon. Bye now.
Is it possible if you can send us steps 1 through 12 slides? PowerPoint slides?
Noodle?
Oh, yeah, I guess I could do that.
Because if he didn't see the screen, then.
Yes, there's nice thing. Unfortunately, too many years of kneeling on concrete floors to make scenery